Hey everybody, today we're doing section 2.7, even and odd functions and symmetry. And I know that you've all had geometry before, so you are familiar with the word symmetry, but we have three different symmetries that we're going to be discussing in terms of all these graphs of functions and non-functions. We have first symmetry with respect to the x-axis. That means that your x-axis is your line of symmetry for your graph. Another one we're going to be talking about is symmetry with respect to the y-axis, and that means that the y-axis is your line of symmetry for your graph. So a parabola that's been moved up or down is an example of a function with symmetry with respect to the y-axis. And then the last one we're going to talk about here on this video is symmetry with respect to the origin. And that one is a little bit different, and we'll talk about that one once we get to it. But that basically means that you can flip your graph, you can rotate it 180 degrees, and the graph will look the exact same. So a little bit different. It's not exactly a line of symmetry, but we'll talk about that when we get to it. So the very first one we're going to talk about here is symmetry with respect to the x-axis. We have all these bullet points here. Contains the point x comma y, also contains the point x comma negative y. So one thing to be thinking about is that if you have x-axis symmetry, that means that it's your y value that changes. Because think about it in terms of this. We have the point x comma y here, and if you make the y value negative, then you end up down here, which therefore gives us our x-axis symmetry. Okay, so just kind of think about that. It's a little confusing. X-axis symmetry has the point xy and x negative y. And we have an algebraic test to be able to figure out, just by giving the equation and not a graph, to see if it has x-axis symmetry. So what we're going to talk about here for this first one is look at this example, and the test that we're given, it tells us to plug in negative y for y and see if we get the same equation. So that means I'm going to replace in this equation negative y for y. So I'm going to keep everything the same except plug in negative y instead of positive y, and then simplify. So that gives me x equals negative 2y plus 6. So now what I'm doing is I'm comparing this equation that I simplified to this first equation. And are they the same equation, yes or no? No, they are not the same. And therefore, that means this does not have x-axis symmetry. Okay, so all you're doing is you're plugging in negative y into the original equation. You're changing y and replacing it with negative y, and seeing if you get the same exact equation. Let's try the second one, because this one's a little bit different, so it'll be a little bit of a better example. Let's take our original equation and plug in negative y for y, and then simplify. Well, isn't the absolute value of negative y, isn't that just the same as the absolute value of y? The negative on the inside of the absolute value kind of disappears because it's an absolute value. Therefore, these are the same equation. Therefore, it does have x-axis symmetry. Okay, so think about kind of what we talked about yesterday in class. Doesn't that mean that it's an absolute value flipped on its side? So it's kind of the same as this parabola that we have a picture of up here. It's just an absolute value graph, and therefore the x-axis symmetry does apply. Only other thing to think about in terms of x-axis symmetry is if it has x-axis symmetry, it is not a function. I mean, here's your perfect example right here. That thing has x-axis symmetry, but it does not pass the vertical line test. So if it has x-axis symmetry, it is not a function. All right, let's move on to y-axis symmetry. Here we have a basic parabola example, and it has y-axis symmetry. The y-axis is my line of symmetry here. And we have the point x comma y, and we have the point negative x comma y. Think about if you just change the x value to negative, that's still on the graph there, and that's what gives us our y-axis symmetry. So here's our test. It's the exact same as the x-axis symmetry test, except we're plugging in negative x, whereas up here, we're plugging in negative y. Okay, so that's something that you need to kind of keep straight. And then what we're going to do is see if we get the same equation out. And the last thing is, if it's a function and it has y-axis symmetry, it's actually called a special type of function. This is actually called an even function. Okay, so that's something that's important to note the difference again between having y-axis symmetry and x-axis symmetry, is that remember, if it has x-axis symmetry, it is not a function, because here is what the graph looks like. But if it has y-axis symmetry, then yeah, it is a function, and it's actually called this new vocab word down here. It's called an even function. So yes, you need to know the difference between those. Okay, so let's do the test. And again, what we're doing here to test is we're plugging in negative x for x and seeing if we get the same equation back. So this very first one, I'm going to say f of x equals negative x squared plus 4. All I'm doing is replacing the x with negative x, and then I'm going to simplify. So remember, isn't it when you square a negative, you end up with a positive every time? So when I simplify that, yes, these two equations are the exact same. So we have the same equation. Therefore, it has y-axis symmetry. And therefore, this is an even function. Okay, so let's think really quickly about what this graph looks like to kind of help us. This graph is a parabola, and the plus 4 moves it up 4. So here is what our graph looks like. Yeah, for sure. First of all, this is a function. Yes, it has y-axis symmetry because the y-axis is my line of symmetry. And that's kind of what we were doing there by doing that algebraic test of plugging in negative x and then simplifying. And we ended up with the same equation. And so that's the algebraic way to tell if you're not sure what the graph looks like. Let's talk about this one. So I'm going to plug in negative x for x. Negative x to the third minus 5. All I'm doing is plugging in negative x for positive x. And that's going to give me, when I simplify, let's see, a negative x to the third is negative x to the third minus 5. So now I'm comparing this to this. Are these the same exact equation? And the answer is no, because this is positive x to the third, and when I replace that x with negative x, this is negative. So this is not the same. Therefore, it does not have y-axis symmetry. And that's the test that you're doing. Now let's try this last one. Example number 5. If I replace x with negative x, and yes, I'm replacing all of the x's with negative x, and then I'm just going to simplify. So remember how if you bring a negative number to an even exponent, that's going to make the negative go away? But then when I do negative 5 times negative x, that actually gives me a positive 5x. And so compare this equation to this one. Are these the same? No, they're not the same. The x to the fourth is the same, but this is a negative 5x and this is a positive 5x. So these are not the same equation. Therefore, it does not have y-axis symmetry. Okay, so eventually you guys will be able to do these tests in your head. You'll get a lot better at them. But notice how the only thing that I'm doing, well, that's weird that that doesn't change. Okay. The only thing that I'm doing here is notice how if it does have y-axis symmetry, we call it an even function. But if it doesn't have y-axis symmetry, it is not an even function. That's only if it does. Okay. All right, technical difficulty is over. Here we are on our last one, symmetry with respect to the origin. And literally what that means is you turn your paper upside down and the graph looks the exact same. It's called a 180-degree rotation. And what we're going to do is we're going to do a very similar test, except instead of replacing negative x for x or negative y for y, we're going to replace both of them and then see if we get the same exact equation. And then another important thing to note here is that if it's a function and it has origin symmetry, so first of all, it has to be a function, and if it ends up passing the origin symmetry test, then we call this an odd function. Okay, so think of the O's, origin symmetry, odd function. Just think about that. That's how I remember that. And it's y-axis symmetry that's called even function. That one's up here. So a lot of new vocab. Y-axis symmetry, even function. Remember, if it has x-axis symmetry, then it is not a function. And then the third and final one is origin symmetry. That means it is an odd function. So kind of three things, three new ways of looking at graphs to be thinking about. Okay, let's do this first example. We're going to replace x with negative x and y with negative y. So I'm going to get negative y equals negative x to the third. And then I'm just going to simplify. Negative y equals negative x to the third. And if I divide both sides by negative 1, or if I rearrange this a little bit, I can cancel the negatives on each side just to simplify. I get y equals x to the third. So this equation is the exact same as that one. Yes, it's the same equation. That means it has origin symmetry. And is this thing a function, y equals x to the third? Yeah, that's the function that looks like the snake. Yes, it's a function. That means it is an odd function. So this test tells us a lot about our graph. It is an odd function. Okay, how about this next one? Y equals x squared. Okay, let's do negative y for y and negative x for x. And then let's just simplify. So negative y simplifies to just negative y. When I square a negative number, it becomes positive. And nothing else really that I can do here. If I divide both sides by negative 1, then I get the negative x squared, which is still not the same as the original equation. Not the same. Therefore, no origin symmetry. Okay? And then let's see. Those are the tests that you need to know. Lots of things going on here in this very first three examples, okay? So basically everything that I've kind of typed up in this section, maybe put it on note cards or maybe start like kind of trying to memorize these things. They're all very similar with some very important differences. And then all of this here, new vocab, new tests and stuff. That's how you need to know if something is an even function, odd function, what kind of symmetry it has. Other than that, we are going to think about the rest of this stuff tomorrow together in class, okay? So bring your questions. Thanks for watching. See you tomorrow.